Good day to everyone. Let me start with the question that keeps every e-commerce CEO awake at night. So my question is, did you know that acquiring a new customer costs 5 to 25 times more than the retaining an existing one? Yeah, that's not just a number. Every customer you lose, it's hit your profits. So right now, as we speak, e-commerce business are losing the average of 75% of their customers annually due to churn. So that's quite a lot of average, and that's 3 out of every 4 customers you worked so hard to acquire, and they are gone. But if I told you we could predict not just who will leave, but when they leave, why they are leaving, and most importantly, how to keep them. So today I'm going to show you an AI-powered system that does exactly that. This is just a theory. This is a fully working solution that already transforming how the businesses think about their customers' retention. Yeah, so hello everyone, I'm Sanjula and I'm excited to present my master's research project on enhancing customer churn prediction through Explainable AI, interactive dashboards, and also personalized retention strategies. This project was conducted as part of my MSc in Advanced Software Engineering at the University of Westminster in collaboration with Informatics Institute of Technology, Sri Lanka. In this session, I will walk you through the problem space, the solution I designed, how I built and evaluated it. And also the later part, I will ending with a live demo of the system in action. Yeah, let's go to why the churn matters in e-commerce and also problem statement. Customer chain is one of the most pressing challenges in e-commerce today. That studies shows that acquiring a new customer, as I said previously, can cost 5 to 25 times more than retaining an existing one. Even though the business collect a lot of customers' data, most of them still use old-fashioned or unclear churn models. So these models might tell you who is like to churn, but not when, why, and how to act. So it's like getting a weather report says there might be a storm or something else happening in sometime soon, but there's no in detail, no time ban. Actually, there's an action plan. So let's break down what's typically in a churn prediction systems review. Yeah. So in this binary predictions, customers X might churn, but when, why, next week or next year, there's no anything. So we have to, in black box decision, we have to trust the algorithm. And also we don't have any real-time monitoring. So by the time you realize someone is gone, they have to already switch to a competitor. So that's the main predictions that systems will give you. And this is not just a technical issue, it's kind of a business crisis. So these are the leads to it. We are losing revenue and also campaigns that's not work because they are not personalized. You intervene too late, and if the team is ignore and low trust in AI, they what they are don't understand. So these are the main business crises in this churn domain. So what we set to build? So this is not just another churn prediction model, but a complete AI-powered customer retention ecosystem. Yeah. So our system answers these 5 critical questions. So who will churn? So for these, we are using model like XGBoost, Random Forest, and CatBoost to develop up to high percentage of prediction accuracy. And then we will use survivor analysis like Kaplan Meier estimators and cost proportional Hasmol to predict timing. And then we should use SHAP values to explain every prediction in business terms, and then personalized retention strategies based on individual profiles. And the next best part is the real-time dashboard for monitoring and action. So I think this is the first system to integrate all these capabilities into one seamless solution. So in my aim is to predict churn accurately and also estimate when this churn will occur. And also I'm going to recommending personalized retention strategy actions, and all these things are present through a real-time dashboard. Yeah, let me show you how this works, and you can think it is of an AI-powered assembly line. data flows in, insight flows out, and action happen in real time. So yeah, I use XGBoost for prediction accuracy, and also Random Forest as strong baseline, and CatBoost for handling like e-commerce specific categorical data. And then I move to supervised analysis integration. So in I predict when a churn is likely using the Kaplan mirror, that it will show retention probably over time, and a Cox PH model estimates how features affect in time. So for an example, let's say customer number one has 73% of chance of churning in 23 days, and that's due to poor service experience. So this is the high level of sub-analysis integration, and then I'll be going to the global explanation, which features matters across the board, and also local explanation in why this specific customer is at risk, like using experimental AI we shop. And then I'll go to the personalized retention engine. This kind of rule-based strategies for individual profiles, and we are categorizing into high and low value, and high risk and low management negative feedback. So basically, for an example, let's say high value and high risk, we are moving them to loyalty program. Low engagement categories, we are moving to improve onboarding, and negative feedback going to priority support outreach. And then last step, all the inside are present in a business friendly UI, no data sensitive dictate or anything needed to this. So let's walk through how this system is built and deployed. So basically the core technology we are using Python as a backend, and as usually we are using scikit-learn's lifetime modelers, XGBoost, CatBoost, and so many other things for modeling, and SHAP for explainability. Training we use cross-validation and grid search, CV for tuning, and metrics, AUC, precision, recall, and C indexes. So for the front end, we are building in React. Backend is also, since we are dealing with Python, I'm using fast APIs, so expose APIs, and the deployment I'm using Docker with Azure. So both front end and back end Dockerized and image are built in and pushed to Azure ACR via GitHub Actions. So deployed in Azure VMs, running in Docker for full control. Because why we are using Azure is like it's scalable and consistent, easy rollbacks, and also we can monitor the module architecture and everything. So for pipelines, we are using GitHub, as I said before. So build, testing, everything is done by GitHub Actions. It ensures the reliability, testing, versioning, and speed and everything. So this is not just a prototype; it's kind of a production ready and cloud deployed AI system. Yeah, so the key innovations make the system is different. Like we integrating architectures like email, survival, sharp dashboarding, seamless tools, and also taking when, not just if. It's completely full transparency. Every prediction is explainable and trustable. Yeah, personalizing the at scale and customer specific retention strategies. Yeah, this is more than just a incremental innovation. Like this is it's a shift in how we approach. Yeah, so let me show you how this works in real time in e-commerce data. First, I will show you there are a couple of notebooks I have created. So first one is related to the exploratory data analysis, and then I will move to how we train the data and survival analysis, and also uh, how we use segmentations. So as usual, we are using EDA for exploratory data analysis. These are the model evaluations, and this is the model data. We have the customer's ID, churn, retention, and there are a couple of categorical data, and also some integers and Boolean values as well. Yeah, and the same thing we are doing for EDA. We are moving unwanted and clean data sets. So based on these data sets, you can see the 16.8 customers churn and 83.2 customers do not churn. So in other words, we can say that 16.8 revenue due to customers churn we are losing in here, and then we are handling the duplicate values, data standardizations, and for the correlation testing using grid spec. and also we are just distributing the correlations testing, and then we are using SPMN for numeric features. If I go one particular chart, you can check in here distribution of churn, and also based on the count, the linear, theoretical quantities as well. When coming to this section, testing correlation using spearman, you can see that result of this matrix using spearman shows that no features with strong correlation, but there's only one feature which is negative correlation. 0.1 is 0.4 is churn. So that means that the shorter the subscription period, the higher potential for customers to churn. So yeah, then we'll have done the same plotting and everything. If I go one by one, I would say like comparing with count and gender, there are 62%, 60.2% female, and comparing with male, it's 10.7. Uh, Count is churning with this data set, and yeah, when martial status also we can see we have three martial as a single, divorce, and married, but for churn wise, the most of single martial status is 8.5, other than the divorce and married. So based on problem statement, the following conclusion can be drawn. So if I go based on the martial status, so male customer 8.7, female customer 6.2. So this can be assumed that because the male users tend to churn after finding the products they were looking for. And yeah, and also the churn pattern is more like to log in mobile phones. Yeah, in here you can see mobile phone 59.9, so using computers is like 23.3. So this insight can be leveraged by offering discounts, coupon for customers who log in via mobile phones. So encourage we can retention as well. And then the same plot we are using a distribution coupon for each tenure and for each customer. So this impact examine whether discount promotions in the form of cashback have a significant impact on customer churn, specifically for customer subscription period less than 2 months. Yeah, this churn analysis is done based on the gender for each teen churn customer. So in this graph, it's observed the male customers churn more frequently than female customers within the first 2 months of subscription. So yeah, so blue color is male and green color is female. So you can see before the 2 months, most of the male customers was churn uh, within the subscription period, as well as the martial status as well. So this master setup suggests the single individuals may have a psychology tendency to switch platform frequently and are less loyal. So their choice platform depend on which one offers the most benefits. If it means like frequently switching between different e-commerce platforms, so that can be predicted from this chart. Yeah, and also there are a couple of characteristics being categorical data and number of device and everything. I will not go one by one, since there are so many charts I have did for the comparison. So in here also comparison of complaint to not to churn. So there are only 19.5, sorry, 9.0 customers churned, which is only complaints. And also based on distribution of cashback on customers, there are four different categories. I have created low values, medium values, high values, special values. So I can see high values of both special and values are not to churn uh, by increasing the number of customers. Yeah. So these are the EDA thing I have done in here. So let's go back to supervised learning. So in here also, first we have to do the EDA pre-processing, dropping irrelevant columns, duplicate values, and everything. So in this supervised, I'm using handling outliers for. So at this stage, analysis of outliers will be conducted through the Mahalanobis distance method. So in this, therefore, missing values will be included first using the previously defined methods to ensure the complete data and outlier additions. So yeah, so in here the Mahalanobis distance method used to handle multiple outliers simultaneously, and then we are using SHAP to test to identify which data points are truly outliers, and we can do some scatter plot to identify. Uh, so after all these Mahalanobis distance and SHAP test, it was found like 266 rows of data have less than 0.01 p-values, so which categorize them outliers. So as a result, these rows will be removed from the dataset to ensure that model goes does not distorted by extremely irrelevant data. Yeah, and then we are moving to encoding these categorical data and do the column transformers. So and then one of encoding is doing for categorical data. So data split done by here as in 20% of data to training and 80% to test. 80% data will be used for training and 20% will be for testing modules for one unseen data. So in here we are doing this train and split. So modeling and evaluation. So I have created 5 different modules. First one is related to logistic regression, decision trees, random forest, XGBoost, CATBoost. So in here we are mainly focusing on recall because they help to minimize the false negative. So I have created all those pipelines for 5 different models to check which model is more accurate for my research. So in after doing all the data frames and doing things, I figure out the XGBoost as the highest recall and also test accuracy, precision accuracy as well. So this is the cross-validation recall score. So seems like XGBoost is higher than the others. So for that I have choose the XGBoost with outlier handling. So this is the recall score, test and train, and also standard deviation. So after that we have to handle the imbalance of the dataset, and also since we choose the XGBoost, I am using XGBoost to handle the imbalance. So after handling imbalance, we using two methods, which is undersampling and oversampling. So random undersampling, we delete examples from majority class, and random oversampling, we using duplicate example of the majority class. So after doing this undersampling, oversampling, you can see these test recall of undersampling is 0.84, the best part, and the oversampling is 0.75. So based comparing with undersampling, oversampling, the best recall score was achieved using undersampling method. So therefore, next step you perform the hyperparameter tuning. So hyperparameter tuning also we are using XGBoost to during the hyperparameter. So this is the comparison of recall scores by sampling method without recall requiring the undersampling oversampling. So after undersampling oversampling. So hyperparameter tuning also we are using XGBoost and algorithm, and we use grid search CV, and it will took 5 holes and 1296 candidates, totaling is 6480 fits. So after we doing the parameterize hyperparameter, the model accuracy will be 1902, precision and recall something like this. And yeah, there are comparison I have done before and after parameter tuning. So you can see the difference between the before tuning and after tuning. The confusion matrix, since we are more negative, false positive, yeah, and you can see the after tuning it will only say one, previously it 20. So that's the main advantage of doing undersampling and make it a hyperparameter tuning. So then after that we are moving to sharp valuing. So after doing the sharp value, we are identifying which are the main categories and importance of the features. So sharp also mean thinking that in is the main importance of the feature based on sharp values. So this is sharp distribution by feature. So so this is something we have done for some scatter plots. So in here you can see that customer with short tenure tend to churn. So this is the density and the comparing tenure. So churning years is more than like shorter tenure value customers before 10 months. So in here also customer churn by tenure we are using low tenure with first 2 months. You can see high churn values are there, much higher potential for churning compared to those medium to right churn. So for these kind of insights, we can recommend offer promotions to customers with a tenure of less than 2 months, and also additionally, we can handling complaints effectively can help retain loyal customers. So compare with complaints, and also grocery has the highest complaint rate in here. You can see 30.7 grocery complaint rate. Yeah, and also shown by category. So in this section, the fashion categories product can be purchased every month, so the change rate should not be high. That's why. So they offer different products from what customers had all purchased, we can do as a business recommendation here. So laptop and accessories and mobile are not products that typically bought every month. So that's why the churn rate is not much high in here. So these are the conclusions that I got and also recommendations that we need to do. Check and improve it, increase the data size and everything. So after that, I have done a survival analysis. What after we are getting the data from the SHAP analysis, we are doing the survival, and also in here also we have to do the data pre-processing part, missing values, and after that we are doing these game curves, couple and mirror. So in here you can see that estimate average of customer based on the customer tenure. In here estimate of average customer because at risk, concern and events. So these are the uh, average level of points you can see in it. After 20 months, the customer survival chance is pretty much low. So let's say in these events are something like already 831 customers are churned after before 20 months, and these at-risk customers are hardly not churned, but we have to monitor what's actually happening. So this concern is something like not churned, but we don't know what's actually happened. So the state will be unknown of 3559%. So in here also we have complaint claims curves based on customer scenario. And also after 20 months the customer survival chance is getting low. So that means in this period we have to do all the survival actions. Uh, the same thing for preferred customers and everything. So these are all the things are done by Colab. So after that we are moving customers RFM segmentations. So in here RFM stands for recency, frequency and monitoring. So each factors correspond to specific characteristics of the customers, and this RFM matrix is an important indicator. So in here for recency we are grouping as active, warm, cold and native. So and also we are dividing in categories as well. So in here you can see there are 102 active members and 130 inactive. So as a description, we are recency is less than or equal to 2 days. We are moving to quarter one and also quarter two, quarter three, and third quarter. After we doing this segmentation, so in here you can see the 1902 customers or 33% 78 in here customers made transaction within the last 2 days. And also the warm section is 1,207 and 21.44 customers transaction at least 3 days in here, and cold and active 7 days ago. So this is the segmentation of customers according to their recency values. And so distribution of a recency score as previously segmentation based on recency is important because the most recent customers has made transaction on the e-commerce platform, they more likely they remember the platform and make the another purchase as in the active segment. And this frequency refers to how often customers make transactions. In this segment, there also we have group 4 different groups: low, medium, high, and special. After doing the distribution, 1,225 customers, or else 21% more than 4 transactions in special section, and high 371, medium 2283, low 175. Only one. The majority of e-commerce customers fall into medium frequency, meaning they have only made 2 transactions. And the monetary to spending power or total purchases made by a customer. The segmentation also done by low, medium, high. And this distribution of monetary scopes score like this, and also it represents special 1408, high 1407, 1407, So in this also the monetary values are for each segment have equal percentage distribution. By segmenting based on monetary values, we can identify which customers have made the highest and lowest transaction amounts. Yeah. And then we have to calculate the RFM score for segmentation. So segmentation also we have categorizing for loss potential, promising new, big spender, lost, and best. Yeah, so after doing this segmentation, this is how I implement the basis customer who have recently made transaction and also frequently make purchase and have the highest total transactions. So this one is colored in red, and as well as loyalty customers who have made 4 transactions, big spender customer who have highest total transaction amount. So this is how the segmentations we have created for customers. Yeah. So this is another k-means plot I have done for visualization and stuff. So now we can move to the previous all things are implemented in notebooks. After that, I have moved this whole code to Python and open the APIs for each for dashboards. So these are the main APIs I have written. For SHAP only has metrics to get the metrics, and also get update the updated metrics, churns, RFM segmentations, and everything. So everything was deployed in Azure, and this is how the front end look be. So you can see this is how the UI should be. The predicted churn rate will be 25% for 9. So there are 20% threshold and 287 high risk customers. Average probably will be 88.3. So in current name we have 74.5 will stay, and churn will be 25.8. In here also you can see uh, critical customers based on their data, and you can see the model performance, and also if the new records were updated, we can update the model in here as well. And the feature importance list, this is already we have described in notebooks. So this is the sharp values of each and every imputers. When coming to segmentations, totally we have 5670 and so 56330, and I have divided by 70. All of these we are monitoring average value 180 and satisfaction value 3.04. So in here, those potential loyal and every customers you can see this will be 163, 176, and monetary they are getting 230. Then top payment is debit card. So and also the based on this recency and monetary stats, frequent stats we can get by particular RFM segment details like this for all of the sections. Their score is 5, average monthly stats and everything. This is pretty cool feature. And also when coming to customer prediction, this is something we have already in previous implementation, but we can just send this data and get the prediction and everything just to get the idea of if it is churning or not. And this is something like we have implemented because based on the customer's prediction ID we can get something like when this person might churn and the data and everything. Let's try this. We will get a customer from here. Let's get 50046. Yeah, yes. So because the ID is wrong, it is not in our database. So this customer, when we add this customer, it will return estimate churn months is for it's kind of a low risk, but 14 months take to this person to churn, and this is the expect lost we are hitting $1,008 and customer ID. For the retention factors recommendations, all things are explaining here, uh, and it's kind of a tenure and also the complaint. We have to maintain and suggest the customer who have logged complaints are more like to churn. That means this particular customer have logged so many complaints. To mitigate this risk, it's important to address those resolve customer complaints from effectively, and also this sharp recommendation giving what actually you should do as well. Let's try another person. It's this one. Actually, you can double check because in my collab getting 40 months and also this value is same as here as well. Let's try this person. Everything is deployed in Azure environment. It's getting API request. Yes. Let's double check. Yeah, we took this one 10 months. Yeah, 10 months and zero activity. That means this particular customer might churn, but there's no loss for this particular customer. And it seems like this is cashback issue. This customer who receive more cashback tend to have a high child load. To mitigate risk. This version could business could consider offering a large promotions likewise. I know this customer also had some complaints seems. Yeah. So this is the system that I have implemented. All the things are deployed in Azure virtual machine, and also this GitHub Actions update everything in uh, registry, all the images and everything. Front end and back end two different Docker files are inside this VM to deploy this application dashboard and changes appear. Yeah, we'll go back to the presentation then. So this is just the beginning, and also these are the future enhancements that I'm thinking to do. We learn from the retention outcome, do some reinforcement learning and explanation, and also I'm like to do the NLP. So mobile dashboard, live integrations, multimodal ensembles as well. Yeah, and then thank you for this wonderful presentation.